Assuring the quality and reliability of reinforced digital isolators demands careful, high-voltage characterization. I'm William Resch, High-Voltage Characterization Lab Team Leader for Analog Technology Development at Texas Instruments. High-voltage characteristics specified in the datasheet for reinforced isolation include transient overvoltage, Viotm, surge voltage, Viosm, and working voltage, Viorm. I'm going to discuss how TI characterizes reinforced digital isolators for transient overvoltage, surge, and working voltage to ensure a robust and reliable product design. First, let's discuss our high voltage characterization for transient overvoltage. Now, during manufacturing, every digital isolator is verified to satisfy Viotm per datasheet specification. In our lab, we also want to stress the isolators to determine margin to Viotm by testing to the actual failure point with a ramp to breakdown test. Now, due to the high voltages required and package creepage and clearance limitations, this testing is performed in a dielectric oil to ensure the breakdown occurs through the isolation barrier during the test, rather than through the air or across the package. And we compare the ramp to breakdown voltage distribution, mean and width, to the transient overvoltage specification in order to determine our margin to Viotm. The second high voltage characterization is for Viosm, or surge voltage. Surge characterization requires subjecting digital isolators to multiple IEC 60 specification impulses. Test development for the high surge voltages needed for reinforced isolators required extrapolating both the testing methodology and the hardware well beyond the current available surge test systems and well beyond the VDE 884-10 specification test range currently used to verify reinforced isolation performance. We routinely subject digital isolators to 20,000 volts surge pulses. Ensuring the full surge voltage stresses a digital isolator while limiting the current upon breakdown was a technical challenge we had to overcome in order to stress our product to the limit and still have something capable of performing physical failure analysis on. The last high voltage characterization test I wish to discuss is for working voltage, Viorm. It is another example of testing a digital isolator to the physical limit. Using a time-dependent dielectric breakdown technique, we accelerate wear out of the isolation barrier with a voltage stress in order to determine the operating voltage, operating time relationship. We then extrapolate lifetime or working voltage as a function of this relationship. More importantly to our customers, we thoroughly understand the margin to working voltage, assuring our digital isolators function as rated by the datasheet. Thank you for taking the time to learn how TI's high voltage characterization efforts ensure robust and reliable digital isolators. For more information about TI's digital isolators, visit ti.com/iso.